Welcome, Ms. Vilma, to my statistics homework about decisions in society, epidemics, prediction of the spread of infections. I will be talking about probabilities, and I really hope you enjoy. What is an epidemic? An epidemic happens when a disease spreads to many people in a short time. It can start in one place and then move quickly through a community. Why does probability matters? Scientists cannot really predict every infection or every person who gets sick, but they use probability to estimate how fast a disease will grow. They look at data, how many people are sick today, how many had contact with others, and how fast the disease spreads. These probability estimates help hospitals prepare beds, doctors and nurses prepare equipment, and governments decide what actions are safe. SIR model. One of the most important models used to study epidemics is the SIR model. It divides people into three groups. S is for susceptible, people who are healthy but can get the disease. I is for infected, people who have the disease and can spread it. R is for recovered, people who had the disease and are now immune or safe. The SIR model helps us see how people move from one group to another. As more people get infected, the number of susceptible people goes down. As people recover, the number of recovered people goes up. The simple idea helps scientists predict the shape of an epidemic. Infection and recovery probability. In the SIR model, some infected people spread the illness to healthy people. At the same time, other infected people recover or stop being infectious. So the number of sick people can go up or down depending on what happens in the population. If the disease spreads quickly, the number of infected people grows fast. But if people recover faster, or if fewer people get infected, the number of cases begins to slow down. The balance between how fast the diseases spread and how quickly people recover is what shapes the whole epidemic. This balance helps us understand if the outbreak will become big, stay small, or eventually disappear. The reproductive number. The reproductive number, called R0 or R, tells us how many people on average one infected person will infect. If R0 is greater than 1, the disease spreads to more and more people. If R0 is less than 1, the disease will get smaller and eventually stop. During epidemics, reducing the R0 is important. It can be done through vaccines, masks, distancing, hygiene, or any strategy that reduces contact or increases recovery. Simulation example. Let's imagine a simple example. We have a town of 10,000 people. At first, only 10 people are infected. In the simulation, we can see how the illness spreads from one to another. If people have a lot of contact with each other, the number of infections can grow very fast. The curve in the graph goes quickly as more people get sick. Over the next weeks, hundreds or even thousands of people may become infected. But if people limit contact, stay home when sick, or get treated faster, the spread becomes slower. In that case, the curve grows more slowly and becomes much smaller. These simulations help hospitals plan ahead. They show how many doctors and nurses might be needed. Real example of COVID-19. During the COVID-19 pandemic, doctors and nurses worked day and night. Hospitals became full, and health workers had to take care of many patients at the same time. Their work was difficult and emotional. Epidemic models help guide the response. They predict when a wave of infections was coming and how strong it might be. This helped hospitals prepare more beds, get more equipment, and protect both patients and medical staff. Probability and modeling were used by governments, schools, and health organizations to make decisions. They help save lives in a very challenging moment for the world. Why this matters? Behind every number, there is a real person, a patient who is sick, a doctor who works long hours, a nurse who takes care of people every day. Epidemic models are not just math. They are tools that help us protect communities. They help us prepare before things get worse. They help us understand the future and make smart decisions. Probability turns uncertainty into information. It cannot tell the future exactly, but it can guide us, support science, and help people stay safe. By combining probability, research, and teamwork, society can respond better to epidemics. And together, we can reduce risk, protect lives, and build a healthier future. I hope you enjoyed this topic. Thank you very much for your attention.